Okay, hello and welcome to my channel. Today we're gonna talk about ladder operators acting on eigenstates. So, quick reminder is that your general form for eigenstate in harmonic oscillator is something like this. And when you act on it with a destruction operator or annihilation operator, whatever you want to call it, you would get back this. Alright, and this can be expressed like that, psi sub psi n minus 1. Nah, it's just not right. This, let's try that. Yeah, it's way better. And for the creation operator, you would get an n plus 1 psi of n plus 1. There we go. This is what you would get when you act these ladder operators on an eigenstate. Okay, so we might as well just take a look at an example. Now, example is that you have a state, you have like say psi n. Now you want to calculate the x p x squared and p squared. Okay, so immediately you have your x, which is this. And since when you have these two, you can group them together, get an even function, and x here just an odd function. So what you get in general is 0 with an odd function for the expectation value of x. And you can say the same for p. This is an eigenstate, so it doesn't have a momentum. Therefore, this guy is also 0. What we want to calculate really here is the x squared and the p squared. Right, so remember, x squared, you have x and p in terms of these ladder operators are m2, no, that is 2m omega plus a dagger. You can just say that well, x is proportional to a plus a dagger, because when you do the math, you can plug in the constant later. What you really want to know is just what they are proportional to. Alright. So we calculate x squared, square that. What you get here is this on n. Take this and square it, you get this plus this plus this plus that. And right, oh wait, no, this is 0. Yep. And immediately you can see which term would contribute and which term would terminate. So this a double a on this give you 0, so that term doesn't work. This would give you 2, meaning it is different from here. And by orthonormality, this would also doesn't work since your delta now is equal to 0. Okay, this is n. What am I doing? Okay, back to what I was saying. This would give you n plus 2, and by orthonormality, the delta now is equal to 0, so this term wouldn't work as well. So we only have these two terms to be looking at. And you see that term is, okay, you split that, that will give you 1 plus n, 1 plus number operator, and the other one is the number operator. So I would write this as 1 plus 2n, and on psi of n. Okay, so now this on that, do that, no n, rinse out the n, that would give you, no, 2, which is, well, write them back, that is h bar divide, you can pull the 2, divide them, yeah, instead of 2n, now you get n plus 1/2 instead. Okay, so that would be your x squared. Next would be your p squared. And I think p squared, you can do it yourself. I would be so glad if you comment the method that you get p squared in the comment section. This would be the solution. I would love if you guys show me the step-by-step calculation for p squared, as it is like almost identical to x squared. So I would love to see that. And that's it for today. Goodbye.